Good afternoon, everyone. It is 3 p.m. in the beautiful country of the Netherlands, and today we are all over the world to talk about one of the hottest, one of the coolest, one of the most interesting topics in optical communication, when the light travels free space. Ladies and gentlemen, welcome to the epic online technology meeting on LiFi and free space communications. Wireless communication is taken for granted, but wireless communication with photonics is coming soon. To succeed, we need to refine the right optics to focus the beam at exactly the right position. On Monday, October 26, we are bringing together users that need free space optical communication. So where is the huge need for speed? Airplanes can load up hundreds of terabytes of fresh multimedia content while passengers are boarding. Free space optics could play a role in facilitating massive exchanges of data between ships coming into harbor or between next generation satellites, what some are calling orbital data centers. I have my guest list ready for our Zoom room on Monday, October 26. I want to involve the main stakeholders of the future connected world, from space to smart cities. That includes the companies working in new space, ESA, SpaceX, or NASA, car and aircraft manufacturers like Audi or Airbus, and I want to bring Nokia and Huawei into discussion about the connectivity in smart cities. And with all these people in the Zoom room, let's consider another hot topic, LiFi. Suppose we use light not as a point-to-point link, but in a broadcast concept. For many years, companies like pureLiFi in Scotland have been leading the way. They use standard lighting and reach speeds 100 times faster than Wi-Fi, but doesn't go through walls. So if you are into optics, lighting, communications, and lasers, do not miss this one. You can also follow us live on YouTube as we kick off at exactly 3 p.m.
Thank you very much for being here today. It is an exciting day. It is an exciting day to talk about free space optical communications and LiFi. I'm here speaking on behalf of the European Photonic Industry Consortium, telling you that we are extremely happy for what we are achieving. Many of you know that 2 weeks ago, EPIC became the largest photonic association in the world, and I'm so happy to be part of that. Not only me, but also the rest of the EPIC team, who are putting together an online platform. We were very present in the day-to-day basis, traveling 200 days a year and visiting everyone. Now we make everything online. And many of you are very aware of online technology meetings. For those of you who are not, please check the topics that we have already announced all the way to Christmas. And if any of these topics is interesting for you, and for many of you, quantum communication, QKD, 3D sensing, photonic for pharma, LiDAR for industry automation, whenever any of these topics interesting for you and you want to meet your potential partner suppliers and customers, you have to join the EPIC online technology meetings with a clear focus on end users. And as I said before, I'm talking on behalf of a fantastic team. EPIC has 14 employees full-time, half of them with PhD positions, and what we do is very simple. We organize focus events scouting end users. We provide access to a network of experts. So you're looking to get in touch with any company, tell us and we'll make it happen. We also raise investment. So if you are looking to raise capital for the future growth of your photonic industry, let us know and we'll connect you with the right investors. We have the biggest website in the world, to find a job in photonics, www.jobsinphotonics.com. Have a look at it. And we also have a long list of market reports, free access for the EPIC members, a clear membership benefit. If your company is not a member of EPIC yet and you want to join EPIC, all you have to do is send me an email and I'll make it happen for you, of course. But today is all about you. Today is about free space optical communications and LiFi. I would like to acknowledge, to thank the support of our sponsor companies today. Without you, we wouldn't be able to make it happen. So thank you so much, Civan, all the way from Israel, making ultra-fast, high-power lasers. Akmar, the company that makes the black coatings. You're looking for large absorption black coatings, you have to contact Akmar. Chroma, one of the best suppliers of optical filters in the world. Chroma supplies any optical filter that you need, actually can deposit into any glass on optic that you require. Optic Balzers, whenever you're looking for any high-end coating, any high-end process, any high-end automation for high-end service for the automation of manufacturing, any photonic device, Optic Balzers is the ideal partner. Axetris, in the world of micro optics, they are very well positioned in manufacturing the micro-optics and actually bringing them to their own instruments. So whenever you're looking for any instrument or any micro-optic based solution, you go to Switzerland, you go to axetris, and finally, last but not least, ficontec, position in the middle of the supply chain for manufacturing of optoelectronic. Ficontec is one of the market leaders in the manufacturing equipment for automation and assembly of photonic integrated circuits, silicon photonic transceivers, LiDAR, anything that requires high-end automation. You go to ficontec and they prepare for you the machine and the process to have it automated. And with this, I'm really happy to give the floor to my R&D manager and better friend, Dr. Ana Gonzalez. Ana, what's in the menu today?
Thank you very much, Jose. Yes, it looks like today we have a very interesting meeting with talks about aeronautics, wearable medical devices, space communications, and LiFi. So these talks will trigger interesting discussions among all the companies in the supply chain in free space communications, providing solutions to the end users attending, such as Apple, Thales, Airbus, ESA, Huawei, and IBM. So it doesn't matter what is your need in photonics, we have here the right company for you to connect with. So we have companies making all kinds of components, lasers, detectors, filters, cables. We have companies doing software for optical system simulation. We have photonic integrated circuits foundries, silicon nitride, indium phosphide, even graphene foundries. We have the entire supply chain in packaging with companies offering packaging tools and process and services. And also companies offering optics, testing and metrology, coating, filters, materials, wafers, and all the relevant system integrators. So, and let me also highlight the pilot lines in photonics in this supply chain. So, yes, we have Fabulous as the, thank you, Jose. We have Fabulous as the pilot line for large scale manufacturing of freedom for micro optics. We have JPIC's pilot line for pilot production of indium phosphide chips, and also PIXA, the pilot line for packaging and assembly of photonic integrated circuits. And yes, about PIXA pilot line, thank you, I have interesting news. So we are very happy to announce today a new call for proposals for the pre-commercial round. So please apply to this call if you have photonic integrated circuits that need to be packaged using processes that are compatible with large-scale manufacturing. So get your pre-commercial package series partially subsidized also by the European Commission if you apply to this call. So back to you, Jose. Thank you.
Thank you very much, Ana. It is incredible what Ana is achieving with PIXAP. Actually, any company that wants to package integrated photonics, you contact her and she managed to find ways for you to get it packaged all the way from training, even the investment part that you need for that. But I also would like to highlight that the EPIC team is working like crazy. We're organizing two online meetings per week, and every meeting you see a slide like this with all the companies engaged. Notice this slide only reflects the companies who registered for this meeting. So you're missing your logo there. That only means that you were not registered. So please make sure that you register for the upcoming online technology meetings. And I also would like to remind all of you that you have to look really, really handsome and pretty today. You know why? Because we are live in YouTube. Hello, YouTubers. How are you doing? Thank you very much for joining the meeting from YouTube. If you have any questions, you can post them in the YouTube chat and I will read them. And also remember that you want to get in touch with any of the participants today. If you want to have a follow-up discussion with them, all you have to do is send me an email, jose.pozo@epic-asoc.com, and I will make the introduction because I love doing that. And this is, of course, also valid for the people in the Zoom room. If you want to get in touch with each other after the meeting, you can send me an email and I will make the introduction. But during the meeting, you can, of course, use the internal Zoom chat to get in touch with each other and discuss. And after the meeting, just after the meeting, you don't have to go back home. You can stay and we'll organize one-on-one private discussion so you can actually do your particular pitch to find collaborators, suppliers, partners, and customers. I think that's all. I think it's time to get the people who really matter in the FSO and LiFi. Today we have one of the success stories of the European industry starting the meeting. I'm really happy to announce Guy-Mael from Airbus. Airbus is the giant that we all want to work with. Thank you very much, Guy-Mael, for being with us. Airbus is the key company that needs to start this meeting. The floor and the attention of everyone goes to you. Really happy today with Airbus, with IBM, with pureLiFi, with Das Photonics. It's going to be an incredible meeting. Guy-Mael, do I have you in the room? I think we may have lost our friend from Airbus. While we prepare the call, the show must go on. So I'm going to go to one of the most beautiful cities in the world. I'm going to go to Valencia. I'm going to go to Valencia first because I love black rice. If you ever go there, you have to eat black rice, but also because I love Das Photonics, one of the key companies who made photonic solutions for the space and for the defense market, as well as other markets. Miguel is the CTO of Das Photonics. Miguel Piqueras, thank you very much for being with us today. Thank you for taking the unexpected role of opening the meeting. The floor and the attention of everyone goes to the beautiful Valencia, goes to you.
Hello, thank you very much for you, Jose, and every people looking this fantastic webinar. It's an honor for me to start the job. So I will try to do it in line with the time schedule I have, and I'm going to share my slides and talking to you some words about us. Okay, so do you see my screens? I suppose. For Das Photonics, well, my talk today is to show you some ideas or our status today about our technology, specifically for intersatellite links communications, but also some words for quantum applications that probably could be shared in other webinar later. But okay, it's nice to talk also today. So Das Photonics, a very quick overview. It's a company founded in 2005. We started as a startup company with venture capitals and from in the University of Valencia, as you have said. We are based already in Valencia, very close to the sea, so you are very welcome to visit us. And we have world-class infrastructure, especially for photonic devices manufacturing. So you can see in the pictures our building and some of our labs. Well, our motivation or our role in this industry is to develop innovative products, but with photonic technology for the sectors or markets for defense, aeronautics, avionics, and space. We are working for a long time, and we have very good, very remarkable achievements. We say that we have 15 years ice breaking in space with photonics. So we have executive tens of programs in photonics, from R&D for increasing ESA contract, commercial contract, and others. We are the first company that has proved in orbit an active optical cable for communication between equipments in space. We have local oscillator and clock distributions inside the payloads, and we have also the first demonstrations. Our first photonic converter in space for analog payloads for the K-band, and the very remarkable milestone of flying the first frequency converter for the V and Q1, for especially oriented for application for very high throughput satellites. So you can see in the picture our evolution during these years, the different steps increasing the maturity of our technology and the capacity and capabilities of our solutions. We are in the state of the art in the photonic integrated circuits designs and solutions for SATCOM. We are participating in some of the most advanced R&D programs for this technology, photonics peaks for space. And well, very interesting things we are working on, especially focusing in the topic of today, are the photonic front end we are developing for intersatellite links, for aggregating capacity using WDM and by 10 gigabit per second per channel. And also technologies for space payloads for the quantum key distribution. We are something that also we're developing. Well, technologies and capacities, we can summarize analog and digital transceivers up to very high speed in digital and very high frequencies in analog processing. We have proven technology of WDM in orbit and space qualified optical amplifiers, frequency converters. We have also an internal program assessed and validated from customers, collaboration with ESA for components up screening and qualification of photonic parts. We have our internal component portfolio and a proven control electronics and very high specialization in photonic solution and control for space hardware. Concretely for optical intersatellite links for communications, the equipment we have in our hands now are optical front ends for flexible, scalable optical intersatellite links. Very interesting, the wavelength of operation on 1550. It's very safe. It could be very interesting for moving from space to terrestrial or aeronautic applications. The solution for aggregating multiple carriers in its intersatellite link connection, and the incorporation of flexibility at an optical level with optical switching for routing and optical bypass and so on. We will see later some details. And concretely, the hardware on the modules under qualification are very low noise optical amplifiers, specifically for these applications. You can see also in the right picture top-level architecture of a solution in which a satellite could have 4 telescopes for intersatellite link and connecting with others in a LEO constellation, and with different optical amplifiers, different MUX and demuxes, and optical switching matrices, and also optical transceivers. And this is what we are working now for ISL applications. And our roadmap is to have a demonstration at TRL5 in this year, at the end of this year, and the qualification and to be tested in orbit in 2023. Here you can see the same picture, but in the context of the complete system. This is a technology under development in the frame of the SODA project under the umbrella of the European Commission. So here you can see more details about the numbers of the amplifiers, the interconnection with the different telescopes with other satellites in a LEO constellation, and a core in the center of optical switching in collaboration with one of our partner in this project. And we are in charge of the say transceivers, as I commented, and low noise amplifier and the routing and multiplexing. So very interesting technology for ISL, but also for its use for defense and for payloads in airborne and this kind of high-end solutions. And at the end, some words about quantum key distribution space payloads. We have similarities with the previous technology, in which it's a piece of hardware before a telescope, and we send photonic signals or photons. In this case, we are developing quantum key distribution payloads for LEO satellites, including random number generators, synchronization transceivers, and single photon transceivers based on faint pulse sources. A very interesting set of pieces of hardware that working together is a payload of quantum key distribution. We are evolving pre-existing proven quantum random number generator solution, so it's a very comfortable starting point for maximizing the TRL and have a solution in short term. The single photon sources are based in the protocol BB84. And also we are redesigning one of our transmitter now flying in a couple of satellites to be modified or redesigned for high optical power transmitter for the synchronization of this kind of payloads. So at the end, our idea is taking the advantage of our milestones and our achievements have commented at the beginning, and in collaboration with key partnership with experts in quantum technology and the design of the system, to be very fast and to be leading the specialization of quantum key distribution for commercial use. So our roadmap is the demonstration of this technology in 2021 and the in-orbit demonstration in 2024. And that's all today.
Thank you very much, Manuel. Super interesting presentation. Let me stop. Very good. So, okay, so then you know that we have an epic question here at the end of each presentation. What can you do for them and what can they do for you? So what kind of collaborations are you looking? I mean, in the supply chain for photonics. So what kind of connections would you like to get during this meeting?
Well, it's a very nice question. We can start from component level. So in this kind of technologies, we use components from others in some cases, and we do the upscreen and the spatialization and the insertion of these components in our systems or modules. And it's always nice to talk with alternative partners, especially European ones, and with characteristic that enables us to use this technology or these components in defense and space market, especially for ITAR restrictions and other. So from component level point of view, it's very interesting for us to receive contact or information from any component that use optical fiber, even filters, active components, and so on. And well, in parallel, other technologies, electronics, and well, we do quite a lot internal development, but we also have partnership with others for developing especially high-speed electronics. So it could be also very welcome. And for system and integrator point of view, it's for us interesting to look for collaborations or partnership for increasing our presence in the satellite and military applications and systems like Thales and others. So this is the view in vertical, I mean.
Okay, thank you. So yes, I am sure we have all these kind of companies in this Zoom room. Now we have a few questions. So Jan from Caleste, would you like to make your question to Miguel?
Yeah, okay, good. Thank you very much. Yeah, my question was, Milan, do you go that far that you also are responsible for the telescope and the pointing? Or do you consider that, let's say, responsibility of one of your customers?
Mm-hmm. No, it's the second one. We are responsible of the payload part before the telescope and the pointing section.
Okay. Then other question, if I can, your quantum key distribution, is that single photon based, and do you need SPATs or any other single photon detection devices for that?
Not really. It's not an approximation of. We are focusing the transmitter, and we are working not in the entangled photon solution. It's for fan pulse, in which we modulate a pulse source with random numbers generated in a quantum process. So we are not incorporating very high sensitivity photodetectors or these kind of things. I don't know if I have answered your question.
Yeah, okay, good. Thank you very much.
Mm-hmm.
Okay, thank you. And then we have another question from Stefano from Bandwidth 10. Stefano, would you like to make the question?
Yeah, thank you, Anna. So, Miguel, I understand from your architecture, from the slide that you showed before, that so you would probably use not standard transceivers, but a laser that you modulate yourselves. My question is which is the output power that you require for this transmission? Is it a standard, like the power that you have from a standard TOSA in a standard transceiver for telecommunications, or do you need higher power for this kind of transmission?
Do you mean the intersatellite links for communication or for the quantum payload?
For the actually for both, but maybe for me more interesting is between the communication between satellites.
Okay, well, it's we are focusing in this concrete development for the low power section. So the very high power section before a telescope for transmitting is out of the scope for high power optical amplifiers. But the system level design, it's in the order of around 1 baud or more. The level we have thinking is around 10 dBms or so.
Okay, so it's still much higher than a standard transmitter for telecommunication in fiber, let's say for metro applications or something like that.
Yes, it's in fact our intention is to use cool lasers to cover the complete temperature range because we should stabilize the wavelength. So in this case, we cannot use uncooled TOSA. We need to use a cool solution. So DFB lasers, we can develop or we can extract a quite large power compared to the TOSA. So at the end, we have a quite large power budget through the system.
Okay, thank you.
DFB laser, have you looked into pixels for this?
No, pixels, no. Now we are working with DFB lasers.
Because of the power or because of the temperature stability? What is the reason to focus on DFBs?
The first is the wavelength stability, because we need the lasers stabilized with a Peltier, so typical cool laser, but also would like to have quite narrow line width and high power, so it's a combination of them. For now, today, it's the best solution is a DFB, cool DFB.
For now, Miguel, because I want Stefano and you to have a chat after the meeting, because I think you can do something great together.
Yeah, I have a couple of ideas. Maybe I will get in touch with Miguel afterwards to see if there's some point of contact. Anyway, thank you very much.
You will be welcome. Thank you.
Okay, so thank you very much, Miguel. The presentation was very interesting. You are doing a very great job in inter-satellite connection. So now let's go to the next speaker. So let's try again with Guy-Mael from Airbus. Very good. Perfect.
Good afternoon.
Good afternoon. So thank you very much for connecting, Guy.
So this is Airbus Space System in Toulouse. I am Guy-Mael de Naurois, and today I'm going to briefly update you on the recent progress we made in the field of optical communications. And the question is, how can photonics disrupt the next generation of laser communication terminals? So Airbus is involved in several laser commissions. We shall start with the direct transmission to Earth. So it's about beaming the data from observatory LEO satellites down to Earth using a high power beam, high connectivity beam. The second one is to relay data from LEO satellites using a GeoNode, and from the ground from assets like airplanes, mobile ground platforms, or maritime vessels to relay those data using just GeoNode. So that's the space data highway that is operational and operated by Airbus in Germany. The third one is using inter-satellite links to interconnect LEO satellites like constellations and geo satellites for global broadband connectivity. Then there's the D-Space missions, so typically connecting Mars to Earth, and the feeder links, where Space System in Toulouse is pretty active in this domain, where it's about connecting with a very high throughput beam, typically hundreds of gigs toward the terabit per second of a cluster of ground stations to geo satellites, and then forwarding the data to users using multiple RF beams. So again, as I said, my colleagues, Airbus in Germany, are operating 2 satellites in GEO, so EDS A and C, servicing 4 Sentinel satellites. And up to today, we've been transferring 2 petabytes from LEO back to Earth using those lasers. So we talk about more than 30 operational links every day operated by EDS. That represents a service quality of more than 99.5% of availability. So the message here is that lasercom is actually is not a science fiction. It's being operated every day by the industry. Airbus has been a pioneer and ready for the next gen. So we are now ready for launch. We're ready to launch a new generation satellites by 23, and we want to demonstrate the next generation, which will be larger telescope system with innovating pointing systems. We want to demonstrate the capacity to connect with the satellites through the turbulence with a very high throughput, and demonstrate the complete end-to-end system between ground, space, and back to Earth. We will also test a new technobricks, which will be based on an analog modulation, and demonstrate that through the atmosphere, and also in the frame of this project to develop ground stations to connect to the geo satellite. So the big question is, and we believe in there, is that photonics can definitely disrupt the next generation. What we expect from the photonic industry is to bring several key photonic blocks to enhance our satellites. So one of the main blocks will consist on integrating all the components of the modem, of the telecom chain, within one photonic chip that will encompass multiplexers, local oscillators, boosters, to reduce the mass and the volumes of the telecom chain. We require also high power boosters, more than 100 watts per channels on the ground. And since the signal will be pretty weak in space, we need low noise, low power amplifiers on board the satellite. The third block will consist on where we start to be active, our phased array, and how we can basically manipulate light and rephase light that have been perturbed by the atmosphere on board a satellite to maximize the signal, and the use of the recent progress of the field of metamaterials to change the world of optics for space systems. And last but not least, developing larger area for coupling efficiency issues on board satellites that are low noise and high efficient photodetectors. So yes, those components needs to achieve higher power efficiency on the payload, has to be compact. We need those components to be robust toward the harsh space environment in terms of thermal and radiations in space. We need it to be fast and to be competitive in price. And so what we see in terms of problems to solve for the photonic industry is to inject light into the system. How do we go from a centimetric pupil to a micrometer chip? So how do we solve this problem of transferring light from macroscopic system to micro to nanoscopic systems? How do we increase the power consumption efficiency of photonics technologies? And how do we find the proper packaging to space qualify those components? So within Airbus, we are building on those mission requirements, building the future for lasercom, and we are basically ready to steer forward photonics specification to match our mission requirements. So thank you very much for your attention. The message here today is that Airbus is open to collaborate on photonics and to turn technology into viable space products. That's the message. Thank you very much.
I have no words, and that's very hard on me. I think you know me, you know how difficult it is for me to stay quiet. It's impressive that Airbus comes to an epic meeting looking for collaborations, and they come with a beautiful, I'm going to call it a shopping list, and I'm going to put it back here for people to keep it in the back of their mind. It is, of course, quite impressive that we have the entire supply chain here looking to solve some of the particular challenges that you have. So many people are asking me to give them the floor now. I'm going to start with a company in Israel, Civan, Elkana. Elkana, we just heard a really nice presentation from Airbus. What do you think we could do together between Civan, Epic, and Airbus?
Hi everyone, good afternoon. Thank you, Jose. Thank you, Guy-Mael. It's a great segue to what I'm about to talk. I'm with Civan Technologies. I'll just move to show mode. And we highly believe in FSO, and the reason is that FSO presents huge challenges for communication. And if we try to list all these challenges, so we have clouds, and we have obstructions, and we have scintillations, and we have fogs, and so on and so forth, we're all familiar with. And as a result, the light is scattered, and also the level of signal is attenuated, and by the time it gets to the receiver, we get really minor portion of the energy, and of course, which limits the distance and also the bandwidth, which is of course bad for communication systems. All I'm saying now is applicable for terrestrial communication, but also for space communication. And at Civan, just as a nutshell, which will bring me to the solution, at Civan we are developing and manufacturing next generation high power lasers. Most of our lasers are in the range of 10 kilowatts using single mode continuous operation of lasers. We have lasers in different wavelengths like green laser. And also we have a huge capability, which is called dynamic beam. We can control the beam. And then we thought, and as we realized the potential of FSO, we realized that actually our basic technology, which is called CBC, can be used also in FSO, and right now we're developing product for FSO. So just to show you what this technology is, we start with a high quality laser, low power source. We amplify it, we divide it, we amplify it again, we run it through modulators, and we amplify it again, and then we combine it. And then we have a backup mechanism. There are several methods, but we get a feedback. We take it into our algorithms, and in return, we give control to each and every modulator to change the phase of each of every amplifier. So while in our industrial products, we have here 1 kilowatts, the output of each amplifier, for FSO, we believe we can cope with 0.2 watts. So altogether, after the combining, we should have 5 to 10 watts, which should be more than enough for any optical communication. But the beauty here is that the combination is done in a coherent way. The fact that we control the phase of each output of each beam, of each sub beam, and we have 32 beams here, allows us to control where we have the constructive interference and where we have the disruptive interference. And by that, we can concentrate the power and the power intensity, and we can also change the location of the beam. So just to illustrate that, if we have 4 sources of lasers, each one has a stain on the target. If we do nothing, we have a collective of all these stains, one big stain with relatively low power intensity. But once we can control the phases, and we control where we have the constructive interference and where we have the disruptive interference, basically we can concentrate all the energy in a spot which is 1/6 the diameter of the full stain, and as such the intensity is in the order of 2, right? So it's 36 times the power we would have had without this mechanism, without this algorithm. And as a result, we get a very high concentration of power and a very high quality beam. Now, this allows us also, the fact that we control the phases also allows us to move. I don't know if you see my video, which is not running for some reason now, but we have the ability also to change the, no, it's not running, but we have, we can also control the location of the beam, and this beam, we can move it up to a range, and all these all together, we actually get several benefits. The first benefit is that we have a coherent combining a beam, which is very good in eliminating the turbulence effect. Each beam goes through a different path. Each one is being affected differently by the turbulences. And so usually FSO beam is scattered around. With our control of the beam, we can consolidate them again. And as shown earlier, we can concentrate all the power into one point. The other advantage is the dynamic beam, which helps us to use smaller receiver lengths, right? We can control where the beam is. The third one is concentration of power. So we get 36 times the power intensities than in usual applications. And the fourth benefit is that we get low fluctuation. Usually in FSO, we would get 10 to 20 dB fluctuation. In our case, we can limit it to 1 to 2. And as we know, communication systems are not very tolerant for fluctuations. And all this is done, the whole round, getting the feedback, adjusting the phase, and so on, we do in 200 microseconds. So in every atmosphere turbulence cycle, we can have 5 times correction cycles. So we are much faster than the frequency of the atmosphere turbulence. So we can get it fixed. Okay, again, we don't see the video now for some reason. But if we would have seen, we have a trial here of 5 kilometers. We have a target, and when our algorithm is on, we see the beam very concentrated, very stable in a small spot. And when we turn off our algorithm, we see the lights scattered around, and basically the amount of energy which is received by the receiver is extremely low. So pity that we cannot show the video. Maybe if I show it this way, you'll be able to see it. No, cannot play media for some reason. But anyway, I think the message is clear.
The message is very, very clear, Elkana, and I really like. I wanted you to summarize in one
Yes.
sentence
Yes.
because it was quite clear what Airbus headache is. Airbus was telling us about power efficient payloads. So in one hand is the power efficiency, and the other one is the payload. I want you to explore what you can do together. Could you summarize this in a concise message?
Yes. So this is our current trial. We run 10 gigabit per second over 10 kilometers, and then we can. The target is to get to 10 gigabit per second. And as you said, this is exactly the challenge that Guy-Mael have mentioned. The turbulences today are limiting FSO performance in terms of distance and bandwidth. We can concentrate the energy in a very high quality spot, much smaller spot. By that, we can extend the range and we can increase the bandwidth. And we already showed that we can overcome atmospheric turbulences, which is a huge challenge for several applications, for terrestrial communication, but also for satellite, air ground to satellite communication.
Very good. Okay, let me give the floor back to Guy from Airbus, because we're going to have a lot of things to present you. Let's stop sharing the screen. I have a lot of things to present to you, but we had the first presentation from Civan. Is this something that you see there is some room for cooperation, Guy? I think we may have seen again.
Thank you.
Yes.
This is a very, very interesting presentation. Indeed, beam combining and controlling the phase at that speed, reaching those amount of power are typically the kind of blocks that the lasercom community in space is looking for. So yes, the answer is yes, definitely.
One of your challenges in your presentation was you were looking for compact systems with power efficient payloads. Actually, you put that twice because I guess it's very, very important. Is there any requirements? Because Civan would like to hear that. Any requirements on the size and volume of the system that you have some numbers for that?
Well, there are two needs. The first need is indeed on board a satellite to recontrol the phase. That would be a minor thing. The most important is to control the phase on ground when you beam up the satellite from ground. So this is where such a technology would be needed. So again, to steer and control the phase of several emitters from the ground to the satellite. So on the ground, power efficiency is less a constraint in terms of power consumption. One of the major constraints would be spectral quality and the total amount of power you can reach within a certain spectral density. So you want a beam which is pretty narrow spectrally and high power and quite stable in terms of phase. What I saw kilohertz of beam control, phase control. That's pretty fast compared to the atmosphere. Indeed, that's a factor above the atmosphere modulation. So that's typically the order of magnitude of where we would be looking for. And then the question is basically the amount of power inside a certain frequency. So having a narrow beam spectrally with high power.
Yeah. Farsad, there are many other people who want to tell you things. I have a question, well, more a question, a comment on room for collaboration with Andreas from Optic Balzers. Andreas, thank you very much for joining today.
Oh, thank you.
I think there is clearly room for cooperation between Airbus and Optic Balzers, right?
I definitely think so, yes.
How do you think you can work together?
I think so let me introduce myself. So my name is Andreas Rahm from Optic Balzers. I'm a space project manager, and I know Airbus already from several space projects. Our company, Optic Balzers, is part of the Materium group since this summer. So we extended our global network. So we are currently present in Jena, in Liechtenstein, in Malaysia, and also now in Westford, where Materium sits. So we are a company working globally, and we are active in several markets. So, and the space market is one of those markets. We are also working in industry, automotive, lighting, and so on. And within the space market, we provide optical thin film coatings, which are highly specialized, especially for deep space exploration, Earth observation, and also for satellite communication. And I think the major part where we can work together is in thin film coatings. So what we supply is optical coatings, which are highly specialized, highly customized in small and medium series for the space market. For instance, highly reflective mirror coatings or multi-bandpass filters as well, with very high blocking, also very narrow bandpass filters with a very high optical density blocking. And also, what is also needed for this kind of communication are sometimes dichroic mirrors. So mirrors which block a certain part of the spectrum and let transmit the other part of the spectrum. I think what is very important for the free space communication is that your optical layers, which play a crucial role there, are space qualified. And this is where our core expertise is. We have quite long mission heritage. So we are presently, our components are flying on several satellites, like Sentinel-2, 4, 5P, and 5. We are also flying to Jupiter soon, so within the framework of the JUICE mission. And we are also present on the Mate Image mission and 3MI mission, where we observe the Earth and explore the climate. And I think with all those spectral components space qualified, we also very well interested in working together for the free space communication with Airbus, for instance.
One of the challenges that was presented by Guy, and it was really interesting, he told us there is some room for cooperation here, clearly specified in the field of space qualification. When it comes to the track record that Optic Balzers has in space, could you comment on perhaps the space qualificationality of the coatings for Optic Balzers?
Yes, of course. Whenever it comes to space projects, there are usually quite extensive space qualification programs taking place, where you test for the damped stability, for instance, especially for radiation hardness, which are very harsh conditions sometimes, depending on your mission. It has to be very long living, because usually you also store the components on ground for a decade or even longer. If you shoot up several similar space or satellites, and there is a whole list of optical coatings and combinations of coatings at Optic Balzers, which are space qualified, which are space proven, which are
Thank you, Andreas.
For...
Let's go back to Guy now, because now he has the ingredients. Guy,
yes.
When we organized a meeting at the European Space Agency a few months ago, I think 1 year and 2 months ago, we had Thales Alenia Space position themselves as the company to space qualify some of the components. What is the process for Airbus to make sure that the components, the photonic components and solutions, are space qualified?
I'm not an expert in space qualification. To answer shortly, basically, we have a department of instrumentation here in Toulouse. There are numerous people who basically test and qualify in control chamber all the components and make sure they're space qualified. So I'm not sure if you have a detailed questions, but yes, this is what we do here in Toulouse on several products, optical products, not only just laser communication, but Earth observations, LiDAR, spectrometer, and there are numerous tests to space qualify.
I had the honor of visiting Airbus in Toulouse, and it's an experience of a lifetime. So if anyone is interested, contact Guy, because it is a tour that really shows you the beautiful path to bringing photonics to space. I have more questions for you, Guy. One is coming from an EPIC member from the YouTube universe. He's at YouTube. The company is called Sun Microsystems. They do amazing electronics. He's wondering, Guy, do you need support and cooperation in low noise electronics and ASIC development?
Yes, definitely.
Okay, I think you should have a chat one-to-one afterwards. And from another EPIC member from Politecnico di Milano in Italy, Masillar. Ciao, Masillar. Thank you for joining today. A question also for you, Guy. He's wondering, phase arrays are implemented through special light modulators. Do you see any future in integrated arrays?
Thank you very much for the questions. This is a very good question. To answer shortly, controlling light with a phased array requires a certain number of elements, just like we're doing with deformable mirrors in adaptive optics. We could do it. I mean, the photonic industry, the photonic community to do the same, to control light using a phased antenna. And the big question is, how do you achieve a nice beam quality, an ACM square, given a certain wavelength, say telecom wavelengths, and given a certain antenna pitch? So the big question is, how do you achieve a nice ACM square given the array that we might develop? And we might expect a lot of diffraction orders that will perturb and degrade the far field, the beam quality. So that won't be one of the key things to achieve.
We have more questions for you. I think I will introduce you to Politecnico di Milano to have a cooperation, because they are very good when it comes to integrated phase arrays. But I have a question from one of my favorite people in the EPIC network, Miss Ruth Huberts. How are you doing today? Ruth from beautiful
Hi,
multiphoton
hey.
optics. How are you
Yes,
doing?
Hi, I'm fine. I just was typewriting the question, so I was very surprised to see the metamaterials already on the slide of Airbus. So what I'm interested in is whether there is a special idea or a special design which is already available, or at least I'm very curious. So how far is Airbus with the meta optics actually?
Alors, for now, there's no concrete technology development. We have several designs that we're thinking about for several users, and yes, I would be happy to share more in a separate session. But for now, we don't have high TRL components available, and we're still looking for partners to dive into the problem of metamaterials. Metamaterials is a vast domain with a lot of different applications: receiving light, emitting light, controlling light. We saw some slide regarding beam steering. So there's a lot of different applications that could be made from metamaterials, and Airbus is now starting over, and yes, looking for collaboration in this domain.
I think that's the perfect answer, right, Ruth?
That is the perfect answer, actually, because we have been demonstrating with partners from the Phenomenon project, where Thales is also partner with, and many others, together with CA Leti and others, that we were able to create very fast focusing meta lens in a very short time frame that it's reproducible. Of course, it's in the beginning, right? It's not yet there that there might be a product, but we could scale that up, and it's a lot of way to go. But therefore, I was curious. I'm very curious in this technology. Thank
Fantastic.
you so much.
One next final comment is coming from Maribon Chaloni from beautiful Light Tech company. Maribon, what's on your mind?
Hello, everybody. Yes, so Guy-Mael, really nice talk. And I'm so joining the comment of Ruth. Metamaterials in Airbus, I was a bit surprised. So I'm used to hear about Airbus that you are using, let's say, pretty well-known and developed technology, and metamaterials, everybody talk about it, but it's not that old. And on my side, yes, so almost you already answered to Ruth, and it's equivalent to my question. It's about design process. If you have some design process already down on Airbus. So on my side at LiTech, I'm working on optical software, and especially one called Airsoft, and is really useful for design of meta lenses. I don't know for Ruth what was the process that was used behind this focal lens based on metamaterials, but yes, usually Maxwell solver are used for that. So yes, it looks like that it's still a really high-level inspection on your side, Guy-Mael, so I guess you don't have design tools right now.
Guy, for design, there is no better partner than LiTech. For the manufacturing, you will be amazed when you see the two-photon polymerization technology that Ruth Hubers and the multi-photon, which is one of the success stories the European ecosystem can provide. And I think, Guy, stay with us because we're going to come back to you, but we need to move on because time is limited, and we go to one presentation that is going to surprise most of you. IBM is making a difference in mobile health. Mobile health and FSO are connected, and Thomas is going to tell us how. Thomas from IBM, thank you very much for being with us. The floor and the attention of everyone goes to you.
Thank you, Jose, for the introduction and having me here. Am I sharing the screen?
Yes.
Good. Okay, perfect. Okay, thanks for having me here. And so I'm talking about the digital health topic. So here at IBM Research, we are focusing on the digital health topic, in particular on chronic disease management. And kind of if you look into the statistics of, let's say, the medicine in the last century, this was mainly dominated by acute events. And so we did a lot of progress kind of in the last century, you know, in the hospital settings and interventions. And now we've seen kind of with kind of the increasing ages and also kind of our lifestyle, kind of the chronic conditions increased a lot with respect to percentage of total death, but also with respect to the cost in the healthcare system. So you can see this on the right. So the new challenge is really to tackle the chronic conditions. Besides currently now, again, kind of infectious diseases coming now through COVID, challenging all our nations. We started several years ago kind of looking into kind of how can we improve the situation of chronic patients. And as mentioned, kind of the current healthcare system was shaped in the last century and is in particularly well in diagnosing and treating patients, typically in the hospital setting. And as mentioned, kind of we should look at kind of the patient journey more holistically, kind of incorporating kind of healthy living, prevention, and the home care element. And we think kind of digital health will have the chance kind of to change kind of the way we kind of engage with patients and can help everybody here. So just looking back kind of what the current state of the art is, kind of medicine relies a lot on patient self-reports. So basically patients will visit physicians from time to time. So basically you get a sparse data set just from those visits. And then also the answers from the patients may be biased strongly through to cultural aspects, social desirability and whatnot. So there was actually a study performed by Chile and they wanted to identify, how many of the patients would answer frankly, these kind of self-reports. And first they asked the physicians and the physicians said, yeah, well, maybe 53% of the answers of our patients are not that frank. And when you ask the patients, it turned out, it's 89% of the questions were not answered as honestly as we wanted. So obviously kind of this has a big effect on kind of how patients are being treated. And please remember, like, kind of these self-reports, they will kind of influence the way patients are being receive their medication. So just as an example, I listed down here, for instance, a questionnaire. So it's a COPD assessment test. So like COPD patients, so these are lung patients, they receive kind of these 8 questions, which they have to answer from 0 to, and evaluate them from a 0 to 5. They have to answer those questions. And according to kind of the final score, physician will provide medication, but also kind of medical significant changes will be evaluated by kind of those 8 questions. So there's a lot of noise in there. And as also mentioned, kind of it's just difficult also to remember like what the last 2 months happened. Did I cough a lot or was it just yesterday that I coughed a lot? So what should I answer? So here we think technology and kind of the miniaturization of technology and the connectivity of technology can help kind of to, get much, more detailed data set and more objective data kind of being reported back to the physician and also the patients themselves to empower them, but also kind of to provide actionable insights to the physicians. So at the patient kind of, okay, you all have seen kind of these wearables or kind of devices which can, kind of measure vital signs. So they can be on the person or they can be installed in people's bed, etc. We can then have kind of the communication kind of into the cloud. And in the cloud, we can, have machine learning algorithms, which from the raw data can then classify individual symptoms. For instance, from waveforms, we can identify coughs. We can identify stress from heart rate variability, etc. And then we can combine different of these digital biomarkers and may report on a disease progression and kind of perform then kind of the, some decisions on how to treat patients. So this is kind of what we then kind of call decision support for the physicians. And one example you can see down here, so this is actually kind of for these COPD patients, we assembled various devices which should be capable of kind of answering the questions listed on the left in an objective and continuous manner. So we combine these devices. So this hub also provides the power to devices. and the communication to the smartphone, communication then to the cloud, and kind of the sensing functionality. And so that's kind of where we think also kind of 3D space optics could kind of play a role. I come to this later afterwards. But so kind of we're handing out this station to patients, and these are like 65-year-old individuals with a medium age. And so technology has to be very easy to handle and to be used. So that's why we just bring technology kind of in this form factor to the patients. But then behind the curtains, we have kind of use artificial intelligence, as mentioned, kind of, to derive the digital biomarkers. For instance, from sound, we engineer kind of features which then feed a neural network, a classifier kind of identifying respiratory sounds. So from here, we can then derive a medical diary. So it's a digital diary where we can identify here, for instance, for sleep, we can identify the sleep patterns of patients during recovery phases. We can identify seasonalities, kind of summer and winter patterns, but then kind of can identify anomalies which could be the result of a sickness or a worsening of the disease, and notification should be sent to the physicians. So beside kind of this kind of pipeline of data processing, we should make sure that kind of this technology is being accepted from a usability and privacy perspective by the patients. So we could think of using sensors which are worn like on the arm to get the vital signs, but then also we can think about using sensors in a bed of a patient to pick up vital signs, for instance. In addition, you may say, okay, you could use video imaging kind of to capture, for instance, falls of elderly people, which is a very important topic. But then people may be concerned about, the privacy of the individuals. So here we're also exploring kind of sensors. For instance, here are millimeter wave sensors, which kind of scan the room and perform a 3D representation with a low resolution. So you can identify objects, but you cannot identify persons. So this is kind of let's say a native privacy maintaining, sensor, if you want. So you could do it off the sensor level, or you could kind of consider on the machine learning level, kind of that you would apply methodologies like federated learning, where your model is being trained on the phone of individual users, so that the data doesn't have to be transferred to the cloud to perform the model update, or you can consider kind of the differential privacy to make sure kind of that individuals are not being recognized in your data set. So that's kind of what we are all concerned about. But then my last slide kind of focuses on the potential opportunities for free space optics. So typically in the applications I was showing, kind of we have like three main issues. Kind of one element is kind of certainly the communication. So it should be low power so that the battery life of the devices is as high as possible. And very important, it has to be really plug and play. So we're talking about 65-year or older people, and they should engage with these devices. And typically we need multiple devices to come to a clear picture about the disease and the health state of the people. So it has to be really plug and play. And here we see like Bluetooth can be very delicate and fragile kind of in using it. On the other hand, also the powering of the devices is a hassle. Several devices, they need multiple charges per day, and you don't get a continuous signal all the time. So here, kind of distributed laser charging could be our very interesting ideas from your community. So we would really like to see kind of such technologies kind of supporting our development and kind of making digital health more ubiquitous available. On the other hand, there's a huge potential also for optical sensing of physiological and behavioral traits. So one example is kind of from Nevisq, kind of fall detection strips. So these are like strips which are placed close to the floor in a room, and this IR sensor strip identifies falls of people. Or then, researchers were using, for instance, the Kinect, so depth cameras, to infer on humans' breath rate. Or you can even, by looking with RGB cameras, you could, by the change of your face, you can, the color of your face, you could identify heart rates. So kind of to identify vital signs without kind of the use of wearables which sit on humans, one could have a much higher compliance with a study protocol. And I'm looking forward really to Mostafa's presentation. So kind of the pure LiFi technology to communicate to our devices in the home setting would be extremely important to make kind of all this digital health technology seamless, available to any kind of population, and to make sure that less people become patients, but that we all are staying safe and healthy. In particular, in the current times, this is very important, and we've seen that it's difficult to go to the hospital, like in special if a new wave hits a country. So many hospitals are focusing on COVID patients, so there's no chance for other chronic patients to visit the hospital. So telemedicine and home monitoring is very important to make sure that the society beyond the COVID patients are staying safe and healthy. Thank you for your attention.
Thank you very much, Thomas. Now I am the one that has no words for this presentation. It was fantastic. Thank you. So, well, you already said what you are interested in. Maybe I know that next talk is for pureLiFi, but maybe Mostafa wants to comment here. So, how do you think this application for your LiFi devices, Mostafa?
Thank you, Anna. Yeah, it's a very interesting presentation, Thomas, and I think you have correctly identified some of the areas where the technology that we're developing can help. It's, well, first of all, secure, because that is one of the key requirements for medical data, as far as we understand, which we can provide. And it can also provide a very high level of reliability, given that it's not impacted by interference from other EM or radio communication systems. So yeah, certainly I can see some good fits here.
Okay, and we are going to have more in your presentation next. Okay, so then Thomas, I would like to introduce you someone, because you told me, you have been telling here in this presentation that you are interested in low power consumption devices. So we have here Smart Photonics in the room. Nazanin, maybe you would like to say a few words about what the Smart Photonics is doing with indium phosphide chips, and any kind of potential collaboration with IBM?
Absolutely. Thank you, Anna. If it's okay, I'd like to actually also share a few slides.
Ah, perfect. You have a slide. Perfect.
Yeah, I've got a few slides prepared. Would be nice to kind of go over that. Okay, is it showing up now?
Very good. You can
Very good.
mode, otherwise it's okay.
Sorry, is it showing now? I'm having a hard time noticing if it's...
Yes, it's okay. Don't worry.
Okay, perfect. So maybe I'll start by saying a few words about Smart Photonics. We're an independent pure play foundry, and we manufacture photonic chips. We manufacture these photonic chips on indium phosphide wafers. So we make discrete components like lasers, tunable lasers, for instance, or you can use these lasers to remotely charge your devices, if you will. And or we can make fully integrated components into PICs, so fully or photonic integrated circuits. We have a very strong foundation. We're recently recognized as Europe's leading independent foundry for integrated photonics. Now, why is what we do important at all? Because I think of what we do as making these chips being the beating heart or the thinking brain, if you will, of some of the modules or some of these systems. It's really cool applications that were talked about earlier for some of these devices. Now our technology can be used, as you see on the screen, in a host of different applications. It's showing up, yeah. So it's used for datacom, telecom, to transfer data, transfer at a faster rate, immersive technologies, autonomous driving, but mainly what we're talking about today, the Internet of Things and medical devices. And some of these indium phosphide PICs truly do offer game-changing performances. So mentioned was the lower power consumption. Definitely you can have lower power consumption using these indium phosphide chips. Some of these capabilities are actually not even possible on different platforms. Now, actually, the pitch I have for you today is not just some of the services we offer, but also how our company, along with about 15 other companies, have partnered together to offer complementary services. This is from consulting, design, simulation, all the way to packaging and assembly of devices. And this is something that's been offered by, or will be offering as JetPIC's pilot line to offer lower entrance threshold for some of these manufacturings, for mature manufacturing. So as I said, we'll take customers from initial consulting, visibility, all the way up and including high volume manufacturing. So the main goals of this pilot line is to accelerate uptake of the PIC, align scalable and interlocking services with the value chain, and accelerate the time to the market with some of with essentially fewer and faster design cycles. And the goal is to be sharing and optimizing the learning across different products and platforms. So I actually believe it would be a very good conversation to have to see how we could potentially help making some of or help with some of the applications that was discussed earlier.
Thank you very much, Nazanin. Thomas, I don't know, did you consider the use of photonic integrated circuits in your devices?
As of now, no. So we didn't do that. So it would be interesting to look into the power budget there. We just have a lot of experience now also with the users, like how the adherence studies to devices, kind of with respect to the frequency they have to charge devices. So the adherence really increases dramatically if you don't have to charge multiple times a day. So if you can kind of go to charging once a week, then like your adherence goes to 90% plus. So that's the goal.
I think that there is a potential collaboration here with Smart Photonics, so maybe we can arrange a call later, okay? So, okay, I think we have another question from here in the chat from Ruth from Multiphoto. Maybe do you want to ask by yourself, Ruth?
Yes, thank you for the nice talk. So when I listen to the power budget question, charging multiple times a day, we know that from our cell phones sometimes, particularly if we use Bluetooth, to one times per week charging. So how far are we away from that one?
It really depends on the type of sensor we're talking about. So we are, for instance, right now, what is really interesting, and now also for studies we do with COVID patients, is kind of the pulse oximetry. And so to get the oxygenation of the blood, and there kind of the sensors are using kind of LED absorption spectrums, and they are the typical devices. They last for half a day. So if you want to, and in COVID we understand that kind of symptoms are changing rapidly. So a full day recording would be extremely useful. So that's why kind of currently we have to go kind of a detour and, just add an additional, for instance, battery pack to the wrist, and the sensor is on the finger, which is not very user-friendly neither. So exactly. So it really depends on the sensor modality as well. So one thing is the transmission of the information, but then like the sensor can be a killer as well.
Thank you.
Thank you very much. And we have another question from Jan from Caleste. Jan, would you like to make the question by yourself?
Okay, yeah. Let's say in the past I've worked together with people of CERT-ITI in Greece on a project called FireSense, where we had let's say, distributed temperature network hanging on trees to detect early forest fires. Let's say having such type of low power but a self-organizing network, would that help also for you to solve the problem of connectivity? And let's say power, because batteries there could survive almost 1 year on one single cell.
Right. Exactly. So I think again it probably depends on the setting. So we have projects in elderly homes, and there you could, I guess, consider kind of to set up a network of such sensors, or like AND+ and so on. But quite often we provide devices to individuals to their home, and then we try to really build a self-contained station which can be handed over, and nothing has to be set up at home. As it may be that not even Wi-Fi is available in such places. So we just have to be fairly robust in a sense, and independent from any other technology. So quite often using kind of GMS connectivity there, but then like the base station kind of serves then all the provides the connectivity. So, but it needs, again, it's in one point of communication.
Thomas, question from the YouTube universe. They are asking a lot of questions. Dirk de Man from a company AAE, which is a company that is a giant in the manufacturing of equipment. They are very excited about your presentation. They're really, really excited, especially about this part of the presentation, which I also got super interested about. They're wondering what partners do you need to get here for your preferred future?
Right. So we are mainly interested in, okay, let's say from the IBM perspective, and I think from also the application perspective, we believe kind of the multimodal sensor integration is relevant. So there's many companies out there which provide one sensor, and they measure lung capacity, or the other guys, they measure SpO2. But kind of to come up with a proper disease progression reporting, we as IBM, we believe kind of we should take the role kind of to combine individual sensors. So we are interested in kind of subcomponents. So you can see kind of these sensors we integrated into this care desk. So they may be from a startup, they may be from an SME, they may be from an established company. So they're, let's say, some are CE certified already, but some are exploratory. So we basically, kind of want to integrate such devices and technologies, and want to run with university hospitals kind of studies, kind of to prove that kind of this technology in combination is the right thing to do.
This is really fantastic. It's the perfect answer, because together we have put a supply chain, put a supply chain to manufacture medical devices. And in the first week of December, we have an online meeting on medical device manufacturing with companies like Philips for the manufacturing, as well as the Anthony van Leeuwenhoek Hospital for the clinical trials. I want you there, Thomas. Final question for you. I love when EPIC members get to know each other. I have a company next to you. Farsad is from the company that manufactures the electronics and photonics. So we are talking about Sun Microsystems, and he's wondering, do you have some demands for low noise front-end electronics?
Not directly now. I mean, it could happen in the future, but I wouldn't have.
I want the two of you to have a chat, because I'm sure that for the preferred future that you present in your last slide, you definitely need to talk to Farsad. But with this, Thomas, thank you very much. Stay on, we'll come back to you. But I want to now talk about pureLiFi. pureLiFi is one of the companies who's making a difference on the photonic European ecosystem. LiFi is a European technology. A European technology that can make a huge difference in the way that we connect to the IoT. I'm so excited to have pureLiFi as one of our 600 members, and to have our CTO, the CTO of pureLiFi, talking to the rest of the community about how we can help them get to their preferred future. The floor and the attention of everyone, no more than ever, goes to pureLiFi, goes to you.
Thank you, Jose. Thank you, everyone, for being here. So I will just talk about LiFi and our company, pureLiFi, at quite a high level, really just a taster. So let me just run into it. So we believe that as the world gets more and more connected, there is more and more need for LiFi as a technology to supplement existing communication systems.
Mostafa, we are not yet seeing your slides.
Sorry, screen share.
It's all right. Screen share. They are beautiful slides. I've seen them already, so I want all of you to enjoy these too. They are coming. Yes, fantastic. The floor is yours.
Okay, brilliant. So just where was I? Yep. So we believe that in an ever more connected world, we have a need for LiFi to supplement and support existing communication technologies. And if we look at some of the KPIs of 5G, for instance, which is currently rolling out everywhere, it's promising gigabit speeds to every end user with 10,000 times the bandwidth, millisecond latency to support really high quality VR experiences, 10 to 100 times more devices in every cell, with a lot less energy consumption to support all of these features at the end of the day. So I think looking at the rate of progress of standard RF or radio wireless technologies, we see that it will struggle to meet these KPIs. We know that millimeter wave is trying to address some of these, but it's still falling a bit short. So yeah, in comparison, when we look at LiFi as a technology going forward, we know that Professor Haas, who's a co-founder with myself at pureLiFi, has already demonstrated 15 gigabits using off-the-shelf LEDs costing less than $1. And we know that the RF spectrum itself is getting to that crunch point where it's not really able to deliver the capacity that the users demand. And that's where we can turn to the optical spectrum and deliver that needed capacity going forward. And because light is a contained technology in terms of a coverage area, we know that we can continue to deliver a very good user throughput and experience in a very dense area with a lot of replication of the LiFi access points, rather when compared to your standard Wi-Fi APs, which really struggle as you get more and more users coming on. So this is really just setting the scene for why we believe that LiFi is a technology that we really need going forward. So what exactly is LiFi? So here's a very high-level diagram showing you what it is. It's a high-speed bidirectional wireless communication using light. So our vision of LiFi is that it's exactly like Wi-Fi, 4G cellular, and so on, with doing exactly the same thing that you're used to, but all of that happens over the optical spectrum rather than radio. So using a LiFi enabled smartphone shouldn't really be any different from using a Wi-Fi enabled smartphone. It just happens to use a different part of the EM spectrum. And because it doesn't use radio frequencies for communication, it's immune to interference, and some of the other properties of the optical medium also makes it a lot more secure and robust. So I just wanted to highlight here again that when we talk about LiFi, it is a fully networked technology, meaning when you have LiFi access points deployed in a space, we support handing over from one light to the next seamlessly, so that you can have that mobility experience that you'd expect from a standard wireless technology. So here's just an overview of the different kinds of free space optics technologies, because LiFi is a term that often gets abused, I should say. So this is a taxonomy of light communication that's been agreed by the Light Communication Alliance. And there are really 4 broad classes of free space optical communications that we can think of. On the very left, we have optical camera communications. So this is where you can modulate the source at a reasonably low speed, such that you can use the camera of a smartphone as a sampling device and pick up the modulation. So that gives you something in the order of hundreds of kilobits, perhaps, of data rate, and is usually used for fixed beaconing type applications that then actually use the backend RF or other data system to pull down additional information. Then after that, we've got what we'd call just standard visible light communications technologies, which are typically tend to be point-to-point, low data rate solutions used for things like indoor geolocation, advertisement, notifications, and so on. And then we've got LiFi, which, as I explained, is almost exactly like Wi-Fi or cellular. It just happens to use light. And then at the very right, we've got FSO systems, which have been around for decades, delivering many gigabits over many kilometers that I think the EPIC members are very familiar with. So this just gives you a context of where LiFi sits in the whole spectrum of light communications technologies out there today. So what are some of the benefits or characteristics of LiFi? Well, first, speed and bandwidth. We have shown that we can deliver multi-gigabit speeds in mobile devices. So really what pureLiFi is attempting to do is bring free space optics or light communication technologies to the consumer here and deliver the consumer experience, which needs reliability while being very price sensitive, as an example. The quality of the connection is something that sets us apart from traditional radio as well, because as I explained, LiFi, even though it is fully mobile and wireless, it is very well defined in terms of coverage area, and it is very easy to manage interference between multiple access points, which means that any user communicating over LiFi really gets almost like a dedicated wireless channel, which can be comparable to a wired link when it comes to connection reliability, latency, and so on. And then finally, the security is probably one of the key features of LiFi technology. Again, by virtue of light being limited or constrained by solid objects, it's very easy to have a fully secure wireless network using LiFi, which isn't really possible otherwise. So I think it's by virtue of all of these characteristics that we really see limitless applications for this technology in many, many, many different industries and verticals, ranging from defense and harsh environments all the way to consumers. So the markets or industries on the left probably represent the early beachhead markets, where things like feature and security are probably more important than, say, the current size, cost, or whatever else. Whereas the future we're working towards is very much at the right, where the consumer has a LiFi-enabled device, and you don't necessarily even have LiFi there as something visible. It just works. It's in the device, and it's at a price point that makes it suitable for those consumer applications. So here's just an overview of the products pureLiFi has developed over the years. So the company was founded in 2012. 2013, we launched our first product, which was a tethered LiFi solution. 2014, we took that to a mobile form factor. That's rather large, but it's always going smaller from there. 2015/16 is when we launched our very first USB-powered dongle device, which went through an iteration of industrial design and further industrialization in 2017. And this is our LiFi XC product. 2018, we released the very first LiFi ASIC to the market. And then currently we're working on miniature LiFi components that are ready for integration into mobile handsets. So LiFi is here and LiFi is ready. So there are two big industry activities that we've been chairing or leading. One is on the side of standardization. So I think last year, the 802.11bb task group was officially launched, which is looking at standardizing LiFi as a technology within the wider umbrella of the 802.11 or Wi-Fi technologies. So I think that gives you a sense that the IEEE doesn't actually sees this as something that sits alongside Wi-Fi, and we're able to actually leverage a lot of that Wi-Fi infrastructure and framework, and essentially bring a lot of benefits by operating in a different part of the spectrum. Alongside that, we have also kicked off and pulled together the Light Communication Alliance, which is really looking at things like logo certification and so on. So really to have an industry body which is responsible for certifying LiFi devices once there is an agreed standard and feature set. And you can see that there are quite a few big names on the right there. So in terms of deployments, we have well over 200 deployments in 20 different countries across quite a large number of use cases. So just a bit about the company. As I said, we were established back in 2012 out of the University of Edinburgh. We are still very much based in Edinburgh, here in Scotland, with commercial offices around the world. And we are very much focused on pushing the engineering forward to make consumer LiFi a reality. And so from that perspective, I think some of the things we'd be looking for are things that really help us develop consumer-friendly LiFi components at a price point that's in the single dollars, not hundreds. So the technologies that we'd be looking for are, well, actually, interestingly, some of the things that Airbus mentioned earlier, such as large area, high bandwidth detectors, which also need to be very reasonably priced. And also things like high performance filters, optics, CW, low power lasers, and so on and so forth. So that's an overview of pureLiFi and the LiFi technology that we've been working on. Thank you.
Thank you very much, Mostafa. Very interesting presentation. So then you are looking for companies able to make large-scale photo detectors, right?
Yes, large area, high bandwidth photo detectors would be something we'd be interested in.
Okay, and your second request was?
Optical filters, particularly with very low angular sensitivity. So thin film, low angular sensitivity optical filters.
Okay, thank you very much. So we have this kind of companies now in the room. So I guess, well, if you want to participate, I can give you the word. Right now we have a couple of questions here in our chat. So we have yes, Tiger from Senko. Hello. Long time no see.
Yes.
How are you? So do you want to make the question by yourself?
Sure. Thank you very much. Mostafa, thank you very much for a nice presentation. I've got a few questions. What kind of facility size does the LiFi typically applied? And also, if they're big enough, do you use the fiber optical backbone network or still using some kind of copper backbone?
So to answer the first part of your question, what is the typical deployment size or environment? Normally, we deploy in indoor scenarios, such as meeting rooms and offices and so on. But one of the beauties of the LiFi technology is that it's actually very easy to modify the optical beam profile to serve arbitrary distances and coverage areas. So alongside these standard indoor applications, we have also had applications that may be things like high bay ceilings, long-range outdoor comms, and so on. And as for the backhaul question, today, I think where we are in terms of performance, gigabit Ethernet backbone is still sufficient. But as we look to the future at multi-gigabit LiFi deployments, then of course we need to start thinking of fiber optic or other such high-speed backbone that can support that.
Sounds great. Thank you, Mostafa.
Okay, and now we have here a company in the room, SunX. Ben, I don't know if would you like, it's a good moment for you to introduce your company now.
Good afternoon, absolutely, yes. Let me share the presentation. I have a few slides very shortly. Can you see this?
Yes.
Perfect. So, yes, thank you for the introduction. We are SunX in Aachen. We are a young company founded in the year 2011, but really started business in the early 2013. We are coming from a Fraunhofer Institute here, from production technology, and we had a revenue last year of about 2.5 million euro, and our focus is ultra high precision optics manufacturing. For doing that, you can see a picture here of our new facility that we moved into early this year. We have climatized environments and clean room areas that we can use for packaging. So we have, I would say, a very high-tech environment for producing high-precision optical components. Besides the optical components themselves, we also produce ultrasonic tooling systems. I just want to mention that quickly, which are used for ultra-precision diamond turning of special materials that are normally not machinable, such as stainless steel, Invar, or glass, or other materials. But let's focus on the optics. So the process chain that we offer here in our company, you can see quickly here. We start supporting in the optomechanical design. We do the pre-machining of any optical components, such as metal mirrors. Our core competence is the ultra-precision machining of the optical surface. We apply coating onto these surfaces. We do verification, the metrology of surface roughness, and form accuracy, for example, and we can do sub-assembly of systems. At the moment, especially for the satellite communication systems, we are working on a few projects with companies doing some prototypes and small series, but we are set up to be able to cope with larger series, and with this type of products we're talking about probably a few hundreds to a few thousands per year. And I would like to show you just a quick example of one component that we recently made for a TMA, a so-called 3-mirror anastigmat, which is an optical mirror system for example, for a satellite communication unit. And here you can see one mirror on the top left with a gold coating. This is an off-axis mirror. The rotation of this optical axis is not on the surface, so it's basically a piece of an optical surface outside of the center. And the part is measured, the optical area is about 120 millimeter in diameter. And we achieved a surface form accuracy, you can see on the right, on the picture on the right, of 250 nanometer and about 50 nanometer RMS, which is the wavefront deformation of the surface. And the roughness that we can achieve on such surfaces is about, depending on the geometry, between 1 and 5 nanometer RQ or RMS. So this serves as a quick introduction into our company and an application example of what we can do. What we're looking for companies that are involved in larger manufacturing projects that require optical components, and we would be very happy to be involved in these projects. We can make small lens arrays from tiny optics to large optical mirrors into the several hundred millimeter range. We're very happy to discuss those applications. Thank you.
Thank you very much, Ben. Of course, for all the companies with the needs in mirror manufacturing, you are a perfect company. So, okay. So now I think I have another question. Yes, I have another question in the chat, also talking about micro optics. Music from axetris. Would you like to make the question by yourself?
Thank you, Anna. Hi, hey. Hi, Mostafa. So we are manufacturer of micro-optics located in Switzerland. So my name is Menshik. So for high-speed signal transportation, even in LiFi modules, I guess you will need optical transceivers or TOSA or LOSA sub-assemblies, I guess. So if yes, do you work with a partner, or are you building your own transceivers or like TOSA or LOSA in LiFi modules?
So we do build our own sub-assemblies because
Okay.
I think this is where some of our specialty actually lies, given that the LiFi broadcast environment is quite different from your typical ROSA and TOSA applications. So today we do build our own, but we might be open to looking at partners who can help us with that.
Okay. So if I think you will need as well the micro optics in your sub-assemblies, I guess. So maybe we can talk about that later. Thank you.
Sure. Yeah.
Very good. Okay, and last question here from Hamad from OptiWave. Would you like to make the question by yourself?
Yeah, sure. Thanks, Anna. Mostafa, hi, and actually it's a very nice presentation. Thank you. The question is actually about like you mentioned something quickly about the adapter, which you wanted to kind of integrate like an adapter to add to regular standard cell phones or devices to enable the LiFi technology. So I'm not sure if you can provide some more information about this kind of adapter, if you want to call it, or anything else.
So what I can tell you is that the 802.11bb standardization group is looking at reusing existing Wi-Fi chipsets within devices to enable LiFi communication. So essentially, today we need an adapter that can translate the radio to baseband signal for the optical front end. And I think going forward, as the technology matures, it may be that the 802.11 basebands are capable of generating the required baseband signal directly as well. So I think that's in a nutshell where it is at the moment.
Okay, and is it possible, like, for members to be added up to this consortium, to IEEE? Like, or is it open for people to add up to this consortium?
Well, I believe the IEEE is an open forum.
Yes, it is. It is fully open. Actually, EPIC is cooperating strongly with IEEE 802. So if you are interested in provide any input to any of the work packages, in IEEE 802, especially .3 and .5, but also these ones, we have the right contact people. So this is open for all of you, and also people in the YouTube. Hello, YouTubers. If any of you want to provide input to any of the work packages of IEEE 802.x, you can just contact me, Jose Pozo at epicdataset.com. I will be more than happy to provide that help.
Perfect. Thanks, Jose.
Okay, sorry. So then let's move ahead in the program. So I am the great pleasure to introduce you Ernesto, who is going to, well, he is one of the pioneers in development of LiFi in Europe. And yes, thank you, Ernesto. The floor is yours. Hello, Ernesto. We cannot hear you. I don't know if, are you mute? Hello?
Ernesto, we have you muted and we want to hear your beautiful voice.
Okay.
Ciao, Ernesto. Va bene? The floor and the attention of everyone goes to you. You have to share. Yes, perfect.
Yeah, that's fine. Okay. Thank you. Good evening to everybody. This presentation is a little bit different from the others because we are going to talk about the research activities. So we are not doing products at Scuola Superiore Sant'Anna is a university. We are solving problems to the industries and developing new concepts for the benefits of mankind, let's say. Sooner or later, we may make products with a spin-off, but this is another story. So in this presentation, I will present our most recent realization of optical wireless communication systems for different applications. The key feature of this realization is that we always use COTS components, so we do not need the special devices. The cheaper, the better. A typical example is shown here in this black picture. You can see a lamp that we have adapted. We did not change anything in the lamp, but the electronics which is out of the picture to transform the lamp into a LiFi transmitter. Here you can see a smartphone used for localization. You can see other realization that I will describe later. In this presentation, I'm going to cover a wide range of application scenarios for optical wireless communication. First, I will briefly summarize indoor links and localization. Then I will touch upon underwater optical wireless communication, which is quite new. And finally, mention space application. For indoor optical wireless communication, this is the first demonstration that we did. As I've mentioned, we have adapted a common lamp without changing much, but just the driving electronics of the lamp to allow transmission of a video from one PC to another PC. This is using Ethernet protocol. So we try to change the lowest amount of things in the architecture. However, this type of communication has the problem of the receiver. The lamp is a common lamp. Well, actually, it's very expensive in this case, but it's, let's say, a commercial lamp. But the receiver is something that the user should buy. Localization can be obtained using a common smartphone. So you don't need to convince the user to buy a new piece of equipment. And this is a demonstration that we did together with an industry, which is now planning to have a product launch in next year. Localization based in indoor environments based on a common lamp and a common smartphone. Something more, let's say, future-oriented, blue sky, is communication in data centers. We have demonstrated solution based, again, on existing components for 40 gigabit transmission for top of the rack in data centers. But I think you have heard about indoor application. I think underwater is quite new because underwater is a new frontier. Actually, you probably know that we have a very limited knowledge of what is under the sea. Only a very small amount of the sea has been completely explored. And today this is possible because we have robots that can perform exploration and monitoring of the seabeds. Of course, the robots must exchange periodically data with a local hub, such as this buoy, which is indicated here. And to this aim, we have designed and realized underwater optical modems that use blue LEDs, common photodiode for monitoring, and APD for detection. This is a 10 megabit underwater optical wireless communication modem that allows bidirectional transmission of 10 base T Ethernet. And this modem has been not only realized and tested in the lab, it has been tested in La Spezia Harbor in sea trial in NATO Center in Italy. You can see the picture here of the test. So this opens quite a new scenario for optical wireless communication. Now we have been touching upon indoor and underwater, and now I'm going to talk a little bit about another environment where we see a possibility for optical wireless communication to flourish. That is space. We have now currently ongoing an ESA project with Thales Alenia Space about realizing optical wireless communication for spacecraft. Indeed, we can have optical wireless communication in intra-spacecraft, extra-spacecraft, and assembly, integration, and test. The key point here is to reduce cables. Cables represent a significant amount of mass and cost of current spacecraft. So if we are able to remove the cables effectively with optical wireless, we improve the economics and also the time to market of the products. And here you can see our first prototype of optical transceiver for existing communication protocols for space equipment. Space does not mean just onboard communication. Space also means, as it was indicated by Airbus, communication between satellites and Earth and among the different satellites. So to this aim, I would like to recall our, let's say, record experiment we did more than 10 years ago. It was 1.28 terabits, optical wireless communication, free space on terrestrial in outdoor. It was the first ever demonstration of terabit communication, WDM, in terrestrial environment, and it was enabled by transparent terminals. Transparent terminals means that you connect the free space directly to a fiber. So you can allow bidirectional transmission in this case, transmission from A to B and from B to A. In this case, there was a loop back. And it's also possible by transparent terminals to have WDM, or to change the bit rate, or to change the modulation format. You can do whatever you like, because from point of view of system engineer, the whole free space link looks like a piece of fiber. So, and this, as I mentioned, was tested over free space in our campus area. And this is a picture from Google Maps. I'm mentioning this because today, European Space Agency has proposed a new concept of transmitting huge amount of data between satellites and Earth, among different satellites. And the concept is indicated frequently as Hydron network. And in order to achieve the huge capacities that Hydron needs, you need the transparent terminals, such as the ones that we have introduced 10 years ago. Of course, this is not simple. This is still under study. Feasibility and architecture study is ongoing, and we are also involved in this type of activity.
Thank you very much, Ernesto. I really wanted you to give a presentation today because for many years you're giving input to EPIC about how to position LiFi and other VLC and other communication technologies into the EPIC network. Okay. And you played a huge role. But today I knew that you were working on this FSO underwater. I'm very, very excited about this. This for me is a paradigm shift on potential cooperations. So I want to specify a bit more what are really the shopping list here, because you should all know that Scuola Sant'Anna is actually enabling many collaborations, and they are also very linked to the Fundación Infotech. So we are looking for partners constantly. If you think about the system that we have here with the photodiode, the blue LED, what would be your Santa Claus Christmas list to make the next generation experiment of FSO underwater?
At this moment, I would say that as a Scuola Superiore Sant'Anna, we mostly need end users. So this is a technology which is very promising. I think we are the only one to have demonstrated really in the sea, in a harbor sea, underwater optical wireless communication in this condition. Also demonstrating the interaction of the modem, the integration of the modem within a real network, because the modem realized a piece of link which was integrated in a real network.
The end users are, of course, the cherry on the top of the cake of the online technology meetings. Today you had the Airbus, today you had IBM. We're organizing a meeting on aeronautics and naval in a few months, actually it's in December. So keep connecting, keep interacting to do the end users. I think it's Ernesto. If it's okay with you, I think it's time for our last speaker today. It's been such a great meeting. I want the last speaker to send us off the way that this meeting deserves. So for that, a company in the field of manufacturing, which is what it's all about, wants to give the closing speech. And Glenair, Ron Logan, my friend Ron, has this honor. Ron, send us off the way we are supposed to. The floor and the attention of everyone goes to Glenair, goes to you. You know, one thing I noticed with this, my friends, they used to be always shave, and now with the pandemic, they all grow a beard and they look fantastic. So I see my friends from Bay Photonics with the beautiful beard, Optical with the beautiful beard, and Ron also with his beautiful beard. You look fantastic, Ron. The floor and the attention of everyone goes to Glenair.
Thank you. Thank you, Jose. Can you see my
I see
slide?
them crystal clear, yes.
Okay.
I know, but you're sharing the wrong screen, which you're going to solve. Yes.
Oh, okay. Swap the screen here. Hang on a second.
Yes.
Does that work? Okay.
Perfectly.
All right. Thank you very much for the opportunity to present today. And I'd like to talk about our photonics technology for free space optical communications primarily. Glenair, if you're not familiar, is a leader in interconnect technology for aerospace and harsh environment industries. We have over 3,500 total staff, including 400 engineers or approximately. We have manufacturing sites in Germany, Italy, the UK, and the US. Very large range of products for interconnect, including high-speed fiber optics, photonics, and harsh environment, even subsea interconnect solutions. But we do a lot of customization of product for our customers. So that's just a very brief overview of the company. And I'll dive right into the topic at hand, which today is free space optical terminals. And I wanted to just indicate a few things about a generic FSO terminal and some of the products that we've been developing around this problem. First of all, in any free space comm terminal, you have your aperture with pointing and tracking. We're not really addressing that. Primarily, we're addressing transceivers, ruggedized for space applications, fiber optic amplifiers, also ruggedized and optimized for applications in vacuum, and both of these in a radiation environment. And then finally, we have a wide range of optical connector solutions to handle the low power interconnects that are typical, but also the very difficult to handle high power interconnect at the output of the booster amplifier and moving to the aperture. In many cases, you're talking about at least 1 watt, and I heard one speaker today talking about up to 100 watts, I believe, was mentioned. So we are developing interconnect technology for single mode and polarization maintaining fibers that can handle these sorts of very high power levels. The challenges here are high data rates, vacuum operation, and space environment, and ruggedization to survive launch. So the first item is our DWDM transceiver. This is based on a DFB EML and available on ITU grid 100 gigahertz channel spacings up to 12.5G capable. And it has a full SFP style SFF monitoring and memory map. So it behaves like your commercial optical pluggable module, except it's much more robust and ruggedized and designed to be mounted using screws to a circuit board, as shown here in this photo of it on its evaluation board. We have extensive adjustability of the parameters and via a graphical user interface to optimize the performance in optically amplified systems in ways that are typically not available with standard commercial off-the-shelf products, including changing the receiver bitrate and sensitivity, transmitter zero crossing, the receiver decision threshold, and also wavelength fine adjustment. to maintain alignment with optical filters and compensate for platform motion, etc. All of the products that we develop are oriented toward a harsh environment and minus 40 to plus 85 degrees C, as well as radiation. Optical amplifiers, just very briefly, we have an erbium-ytterbium booster and erbium LNAs. We can combine these in a single chassis, induction cooled, the high power components for reliable operation in space, with or without thermoelectric cooling for various temperature ranges. We've completed some TVAC testing up to 900 hours, and some low Earth orbit radiation tests have been conducted by some of our customers. These are very low power consumption, very high efficiency. Other form factors, configurations are available. Finally, the high power handling optical connectors handle up to 5 watt power has been demonstrated from minus 40 to 85 degrees C to date. We're working on higher power versions into the tens of watts, and these have low losses, about half a dB or less, fiber to fiber for single mode. And we can integrate that into a 38999 ruggedized connector shell or other types of connector form factors. Finally, I just wanted to mention, not necessarily related to free space optics, but on board a spacecraft, there are lots of data lanes moving around, and we have a variety of parallel photonics solutions to move large amounts of data. 10 gigabit to 25 gigabit parallel optics solutions with MTP connectors, hermetically sealed in some cases, minus 40 to plus 85 degrees C, and passing all of the relevant low outgassing standards. These are already tested for heavy shock and vibration tolerance, and have been heavy ion radiation tested as well, with very good results. Finally, ruggedized MT connectors to pair with this technology, and photonic flex circuits to provide interconnect solutions such as optical shuffles are also available. Pulling all of this technology together, really, this is a concept drawing of a photonic interconnect architecture concept for spacecraft, utilizing many of these products, transceivers, connectors going from the outside to the outside of the box, connectors at a backplane level, MT style, and our photonic flex fabric to interconnect all of these things together, notionally shown here. But Glenair has all of this technology in-house, and really can offer an end-to-end solution for signal transport and integrity, from the data source through to the optical modem, through the optical amplifier and high power connector. So what can we do for others? We offer a wide range of harsh environment interconnectivity solutions for optical, DWDM transceivers, optical amplifiers, handling very high power in optical connectors, and we can fine tune these solutions. We were looking for people to define what they need and evaluate our components and undertake system level testing and collaborate with us. And we can fine tune these blocks to whatever you need for your system. Thank you very much.
Thank you very much, Ron. I love this final slide. This is what we call the epic question. And there's, of course, lots of room for cooperation here, especially what Glenair can do for others. So it is very clear that we can engage with many, many different end users for that. And the idea of having system level testing has been quite defined today, but I want to define it a bit better. When it comes to device testing and metrology, Ron, we have a company in Epic, a company called Photonics. Nolan, are you here with us?
Yes.
Thank you very much, Nolan, for joining. What can Photonics do on the metrology? We're almost done, guys. It's only 3 minutes, 1 minute more.
So I'll be really quick. I just have only one slide to share, so we just go to it. Can you see it now?
Yes.
Okay, so basically for the specific scope of free space optical communication, Photonics is basically developing a lot of different wavefront sensors. Actually, in our, I would say, with the broadband products, definition of products or portfolio. We have some of the large or the highest resolution wavefront sensors in the IR range. So specifically, to give some example, we aim at 160 to 120 measurement points on the phase maps. And with this, what we do is actually we can qualify either directly the source and align the source, or calibrate directly the systems in real time. So for example, if I give some products that we do and some applications on which we have defined some specific solutions, we have a Calio, what we call the Calio multi-wave SWIR, that is typically an interferometer based on a wavefront sensor. So the main advantages of that is, of course, to have a cost-effective solution that can work and that it can make really specific characterization at the working wavelengths. So typically 1,550 nanometers, but that can also work at different wavelengths with the same system. So this is the main difference with, I would say, a piezo interferometer that is used in general. Another kind of application that we have is basically, of course, the characterization of lasers and lasers systems. So for measuring not only the phase, but also the propagation, would say parameters. So the idea of using a wavefront sensor for that is to have a one-shot measurement of typically M² parameters, to have at the same time the intensity information and the phase information, and of course to have also the Zernike coefficients to evaluate the quality of the beam or to optimize the quality of the beam. And finally, what I wanted to show today is also that with 20 years of experience in metrology in IR, or also in visible in UV, we are really able to, I would say, build dedicated solutions. So this is something that we do a lot in space industry. So I heard, I think it was Optics Balzers that mentioned some project like Metimage, like Sentinel, like Euclid, on which we also take parts, and we build also some test stations for them. But we can also use our wavefront sensors for, I would say, more complete and indirect application as OGSCs, so really measurement instruments on the ground for satellites and instruments. So this is really the three.
Thank you very much, Nolan. It is very, very clear. I'm going to go back to Rahm now. I'm going to go back to Glenn. It's one of the manufacturing companies that we have in EPIC, and they are positioned themselves as one of the market leaders on the interconnects in space. When it comes to all the different technologies we have heard today about, is Glen Earth perhaps the right entry point to bring all these new technologies to a space qualified instruments that you actually manufacture every day for Airbus, for Thales, for all the primes in the space industry?
Question to me, Jose?
Yes.
Well, that's a great question. It's a really a different thing to produce the entire instrument payload than it is to produce the components. And right now we are a component manufacturer, and that's really where our strength lies. And we're looking to partner with the instrument and payload manufacturers very strongly and become their trusted partner, and really have them think of us as an extension of their engineering team.
So for all the companies who you are wanting to make instruments for space, and you're looking for a manufacturing partner that is going to speed up like crazy the time to market in space, because of the track record, Glen Earth is the kind of company that can do the manufacturing for you. Ron, you are fantastic. Thank you very much for supporting EPIC. It's been a great meeting. You guys keep making me happy. We talk a lot about different FSO networks. We talk about LiFi as well. We had the taxonomy. I love this slide from pureLiFi in which they define every concept. And there are, most important, rooms for cooperation. With Airbus, about power efficient payloads. With IBM, about low power communication and special integration of different sensor modes, and with LiFi, they are looking for large area photodetectors and optical filters. That made many of you very happy. I want to remind all of you that if you stay at the room now, after the meeting finishes, we do one-on-one meetings, which are really great. I also want to remind all of you that EPIC is here for you, that we love to have you here, that we love the interaction that we have with you, that we constantly love having these online meetings. Remember one thing, if you want to be truly successful at EPIC meetings, The success is in the follow-up, so just make sure that you follow up with all the companies that are representing and they can do something for you. If you want to get in touch with any of the speakers today, any of the participants today, all you have to do is send me an email, jose.pozo@epictaxasos.com. I will make the introduction. On behalf of a dream team of experts on marketing, of experts on technology, of experts of talking, of experts of entertaining like me maybe, I want to say thank you very much for supporting the largest photonic association on this very planet. Until the next time, keep being epic, keep your energies up, and keep your smile on. See you soon. Bye-bye.